Hello everybody. In this ChronoTalk, we are going to talk about what and how are we measuring with the force sensor. First of all, let's talk about what is a resultant force. As you know, a force is a vector, and as a vector, it can be added to other vectors. This addition is made component by component. A vector addition, graphically, is as simple as concatenate the arrows representing each vector, as you can see in the animation. The resultant force, the gray one, starts at the beginning of the first vector and ends at the end of the last vector. There are three forces that contribute to the total exerted force by the person we are measuring. One, the body weight. This component is the gravity effect over the body mass. The value is mass times gravity. Two, inertia of the body mass. This is the resistance of the body mass to be accelerated. This value is mass times acceleration. And three, raw force. This is the force measured by the sensor. Sometimes this force includes the body weight, and sometimes the body weight must be subtracted from this value. These cases will be discussed in other videos. The resultant force is the sum of all these forces. Since the version 2.2, the value shown by ChronoTalks is the projection of the resultant force in the direction of the exercise. In this example, the resultant force is represented by the gray arrow and the projection by the blue arrow. The reason for making this projection is to analyze the force the person is able to exert in this direction and not in any other direction. In this situation, we have only the raw force. Here, we add the inertial component. In this situation, we have the body weight and the raw force vectors. Here, we add the inertial component. In this exercise, we take in account the angle formed between the floor and the sensor. The value shown by ChronoTalks reflects the projection of the resultant force in this direction. The same as the last example, but here we add the inertial component.